Hello guys, so welcome to the second video about logical connectives, and we were talking about in the last one about conjunction and disjunction. Okay, so we were watching example about three propositions P, Q, and R, and we already find the truth value of every one of them. Okay, so P minus 12 is an integer, it was true. This proposition 2 plus 4 minus 6 plus 1 less than 0, this is false, and Vancouver is the capital city of Canada, this is false because Ottawa is the capital city, alright? So this is also false. So we already found that P or Q, looking at this junction, because it's the word or, remember, it's like represented by V, the letter V. So P or Q, if P is true and Q is false, true or false will be true. Okay, so the first truth value is true. So we're going to fill this truth table to find the second one, because here we are going to find P or Q and conjunction negation of R. So we are going to find the negation of R, and we already have P or Q that was found in the last question. We already know that this is true, but we have to find the missing part, all right? So for that, we are going to write a truth table like this, and we are going to do it little by little. So we write first the proposition P, the proposition Q, the proposition R. We already know that this is false, and here we are going to find not R, but the negation of R, okay? So we have here P or Q, negation of R, and finally, in the last step, we are going to find P or Q and negation of R, okay? So we are going to see little by little. Let's start by writing the truth values of P and Q. So P, we found that is true, okay? So we write true here. Okay, now Q, we already know that this is false, okay, so let's write here that it's false. P or Q, we already determined that, and we found that this is true, because true or false is false. Remember that in this case, we look at the truth table for disjunction, okay, for the word or. So in this case, this is true, all right? Now, let's do a negation of R. What is the negation of R? We're going to see the truth value of R. Vancouver is the capital city of Canada. It was false, so the negation of false will be the opposite, so this will be true, okay? And finally, now that we already have this term, P or Q, that is in this column, and we already have negation of R, that is here, we can find this and negation of R. So what will be true and true? This is conjunction, okay? This is not disjunction. So we go to the truth table of conjunction, the word and, that is the little mountain, and we see that true and true will be true, okay? So this is our final answer. This is our final answer for this question, okay? So this will be true, all right? So now we already have the truth table. This is our final answer that we were looking for, okay? So we already have this. Remember, the first step, we find the truth values of the original propositions, and then we start building a table with every piece of the proposition. So it will be first of all P, then Q. We can also add R, but here we are interested in negation of R, but we can also write R in other column. P or Q, that we also need that for this. And finally, all the proposition, okay? That will be the conjunction between this and this. So it will be true and true, that the final answer will be true, okay? Okay, guys, so let's go on and let's see another example with words, all right? So here we have, for example, the proposition P there is life on Mars. And the proposition Q says there is life on Titan. So how can we write with words P or Q? Okay, with disjunction. So what choice do you think that can we choose from there? There is life Mars and also on Titan. Life in Mars and also in Titan. Here we have the word and. This is not possible because this is not and. This is or, the disjunction, all right? So this is not possible. There is life on either Mars, Titan, or both. Okay, so let's see the next one. There is life on either Mars or Titan, but not both. Okay, there is either no life on Mars or no life on Titan. These are denying this. Okay. Okay, what do you think? So in this case will be there is life on either Mars, Titan, or both. Okay, so because in this case we have the disjunction. Okay, they can be both or they can be one of them. All right, so in this case we can say the sentence like this. Okay, so will be the second one. Okay, let's go on, and we're going to see an example with mathematical expressions. So in this example, we have to find the truth value first of this proposition. And they are asking for find the truth value of R or disjunction, negation of P, and Q. This is the word and. So let's do it little by little. First of all, remember that we have to find the truth value of P, Q, and R. This is the first step. So how can we find first the truth value of P? We have to do the operations with fractions here. So it will be 1 over 2. Let's see. Let's copy this part in here in this side. All right. So how can we solve this operation? And we are going to find if this is equals to 4 over 8. We have to transform these fractions with the same denominator. If this is 2 and 6, we have to get the same denominator here to get the least common denominator between 2 and 6, and that will be 6. So by what number do we multiply this fraction to get 6? So we multiply by 3. Okay, to get a 6 in the denominator, to get the same. So it will be multiplied times 3 over 3. Okay, so finally we multiply 3 times 1, 3 times 2, so that makes 3 over 2 over 6. Okay, plus 3 over 6. Equals 4 over 8. And how can we get this result? Now we are going to add these numerators, so it will be 3 plus 3, that makes 6. All right, so that makes 6 over 6, 6 over 6, and that makes 1. Okay, but we can write also much better 6 over 6 to compare. 6 over 6 equals 4 over 6. So you're going to tell me these are the same fractions. 6 over 6 is equals to 4 over 6. No, it's completely different. So this proposition is false. All right. So let's organize little by little the truth value. So the first proposition is false. So P is false. We can write it here below, false. The second one, Q1 is a natural number. Is this true or false? This is true. 1 is a natural number, okay? And the next one, 1, 2, and 3, ellipsis, is an infinite set. So remember that when we have ellipses, it means that it goes on forever. So we have here an infinite set. We don't know the number of elements. So this is true, okay? So we have false, true, and true. Now let's build the table. The first one is R that we have here, then the negation of P that we have here, then this parenthesis, we need negation of P and Q, that is here, and finally all of the proposition, okay, once we have the last propositions. So first of all, the proposition R. Proposition R is true, so let's write here true, okay? Negation of P. If P is false, the negation of P will be the opposite, will be true, okay? Now, negation of P and Q. This is conjunction. So let's see. But negation of P will be true and Q, that is true. So they are asking if true and true, what is the truth value, the final truth value of true and true? Okay, from this and this. So we go to conjunction, true, and this is true. So true and true will be also true. And finally, we find the truth value of R, or this is disjunction, okay, the V, look here, this table. So between the proposition R that we have here, the truth value, negation of P and Q, we already have this result, okay, that is true. So we compare this R with this expression that is true. So true or true, because we're looking at the disjunction, true or true, let's see in the table, true or true will be true. So our final answer is true, okay? This is our final answer, okay, guys? So remember, this is not difficult, but we have to be very, very careful. First of all, we find the truth value of every proposition of each one. We find if they are true or false. And if we have more than two propositions, like this case, we have P, we have Q, we have R, we have to do it little by little. It's like the order of operations, PEMDAS. Do you remember that? So we can solve the parentheses first between two propositions, that this is really easy. The negation that we already know, and Q, so we can solve this. We can solve the negation. If in this case P is false, the negation of false is true, okay? And R, we already have the truth value, that is true. And finally, we got the complex propositions by finding the final truth value. So between R or all of this, so we compare this and this column, okay, because we are comparing R, the result of R, and the result of negation of P and Q, which is true. So we compare this by looking at the table of disjunction. So true and true, or true will be true. Okay, guys, so that's it for now. I hope you really understood. And remember that on next week we will have an advisory twice a week, and we can solve the questions that you may have. Okay, guys, so see you later, and remember to check the last video as well. Okay, see you later, bye bye.